This is video on kinematics of particles. This is 17th video in the series. It talks about collision of particles. As mentioned earlier, this topic of collision of particles while studying can either be taken independently, it can also be taken as part of kinetics of particles. We have chosen to group it under kinematics of particles. Now, this video 7 deals with spring and pile. What I mean is, which will be clear from the problems we are going to do, is you see when there is a spring with a platform and some other body drops on it, or when you are driving pile in a ground. What is pile and all we'll explain on the way. Okay, let's look at the first problem. It says 2 kg mass falls 150 mm on a 1 kg platform mounted on springs whose combined K is 730 Newton per meter. This is 2 kg platform. This is a 1 kg platform and 2 kg mass. It falls on this. Now what is going to happen once it falls? They both are going to have direct impact, and due to the impact both together will get some velocity, and with that they move down. Now what is told to you that if the impact is fully plastic, means both of them go down together, determine the maximum distance the platform moves down. The platform moves down from its position before impact. It means we have to find x. Okay. Now we are going to write our collision equations for impact between this body and this platform. So these are the equations. We'll put the numbers. Mass is 2 kg. So it is 2 kg into, we are writing velocity of u1 as 1.7155. Now this number will come if we do root 2g into 0.15. That is, this is the velocity achieved due to fall through 150 mm. It will be root 2gh, so root 2g into 0.15. Now initial velocity of the platform u2 is 0, so this term doesn't come. And then we have m1 v1 plus m2 v2. Now when we say impact is fully plastic, means E is 0. Therefore v2 will be equal to v1 and we'll call it v. Other way of looking at it is, because they both are going to move together, obviously they will have the same velocity. We call it v, solve this and we get our v. Now this is a v which is imparted to these two masses together. It's a downward velocity. It wants to go down. Spring will keep resisting it. So at some point of time it will stop. We want to know this x. So now we look at this as energy problem, wherein this is position 1, this is position 2, and this is a reference. This is a reference for the potential energy. And we write our energy equation. This equation is discussed in previous videos under work energy principle, and one may want to have a look at it in case you are not familiar with this equation. In any case, I will presume you are familiar, and then we'll put the numbers. F into D is 0 because there is no external force. mgh is 3g, the total weight, into x, the height, because this is reference. Half mv square is half, m is 3, and v square is what was imparted to it, and half kx square, half k is 730 into delta square. See, one may apparently feel that spring, why this delta should come, but the fact of the case is that this 1 kg has already compressed the spring, and that compression, if it is delta, that energy is stored in the spring, and that is half 730 delta square. Now this was all for this position 1. Now for position 2, mgh is 0, half mv square is 0. Position mg is 0 because it has reached its reference level, half mv square is 0 because it has stopped, plus half k into total displacement, this x plus already compression, already spring was compressed by delta, so x plus delta whole square. Now it's not difficult to work out delta, because see here, when this 1 kg has compressed the spring and these two are in equilibrium, we can write m2g, that is the weight of the platform, should be equal to k delta, the spring force, 730 into delta, and therefore you get delta as 0.013. That delta you can put it here and here. Then the last equation has only one unknown, and that is x. It will be in quadratic in x, but you can easily solve it, and that is, you get x as 7.5 centimeter. So they wanted how much it will go, or how much they wanted maximum distance the platform moves down from its position before impact. So that is going to be 7.5 centimeter. See one more problem. It says 750 kg hammer of a drop hammer pile driver. See, drop hammer pile driver is the equipment. 750 kg hammer is this. Falls from a height of 1.2 meter onto the top of pile. See, this is a pile of mass 2250 kg. The pile is driven 100 mm into the ground. Assuming perfectly plastic impact, determine the average resistance of the ground to penetration. Let's spend a few minutes in understanding what exactly is this equipment doing. Now, you know, what is pile? Pile you can very loosely understand as a concrete column which is being driven in the ground. Now, to drive a column, you need to hammer it. So what they do is, this is a standard weight, they keep dropping the weight, and every impact moves the pile a little bit down. So what they have said is, when I drop a 750 kg hammer from a distance of 1.2 meter, how much, well, they said it has gone by 100 mm, they are asking the resistance from the ground. So we'll look at it this way. We will write, see, when it falls 750 kg, you get some initial velocity, and that will be because of the fall through this side. So, and then it will have impact with the pile. So we write direct impact equation for these two. So these equations are this. Let's put the numbers. M1 is 750, and 4.85 number you will get, the U1 value, if you do root 2 GH, that is root 2 G into 1.5. In other words, velocity achieved by this 750 block due to the fall through 1.2 meter. Now U2 is 0, so M2 U2 term won't be there, and on the right side it will be M1 V1 plus M2 V2. But like before, the impact is plastic, E is 0, so V2 is V1, we call it V, and therefore we write total mass 2250 plus 750, that 3000 into V, and we work out V, and which comes to 1.2125 meter per second. Now we treat it as energy problem and write out the terms. See, F into D is 0 because there is no external force. MGH, I take this as reference, or rather this as reference, it has gone from here to here. So it is 300 G into 0.1, 300 G into 0.1 plus half 3000 into 1.2125 square is half mv square, and no spring, so kx square is 0, half kx square is 0. On the right hand side, in the second position, that is when it is driven down by 100 mm, you get mgh is 0, half mv square 0, half kx square 0, only frictional force into the distance, which is 0.1. If you put d as 0.1, we will get frictional force as 51.5 kilonewtons, and that's what was asked, average resistance from the ground